In the first video, we went through a lot of information about unit vectors, and in this video what we want to do is we want to determine a unit vector in the direction of any vector. So let's say that we have vector v is equal to the vector 3, 4. I want to determine a vector v hat, and I put a hat because that indicates it's a unit vector, in the direction of vector v. So what does this mean? If we were to draw vector v, right, so if we take our xy coordinate and I draw vector v in here, so I go over 1, 2, 3, and up 4, here's vector v. Now vector v is not a unit vector because the magnitude of vector v is equal to the square root of 3 squared plus 4 squared. So the magnitude of vector v is equal to 5. And since 5 is not equal to 1, vector v is not a unit vector. So I want to find a vector that's a unit vector that points in the same direction as v. So what does that mean? I'm looking for a little vector down here that has a length of 1 that's pointing in the same direction as vector v. So that's the v hat that I'm looking for. And it's actually quite straightforward to find the unit vector in the direction of a vector. The way that we do it, so the unit vector, move this up, sticking a little bit, in the direction of any vector v is found by taking the components of vector v. So we're going to take vector v and we're going to divide it by the magnitude of vector v. And so what that means is we're going to take the components of vector v and we're going to divide each of them by the magnitude of vector v. And that will give us the unit vector that is vx over the magnitude of v and vy over the magnitude of v. So if I go back to the example we have above, we have 3, 4, and we have a magnitude of 5. And so this little unit vector in the direction of vector v is going to be 3 over 5, 4 over 5, because I'm going to take the component and divide by the magnitude. And so this little vector here, I could put it in decimals if I wanted to, you don't have to, has an x component of 0.6 and a y component of 0.8, and that is what we would call v hat. It is the unit vector that's in the direction of the red vector 3, 4. Now remember, unit vectors would all land on the unit circle. So if I had drawn a circle with a radius of 1, that means that this point, 0.6, 0.8, must be on the unit circle. So if I had drawn, and in fact I can go back to the previous page from our previous video. Oh, yes, maybe I get a couple pages sticking. If I went back to my previous page here and I looked at our unit circle, if I go to 0.6, 0.8, there has to be a point on my unit circle because I just found from this video that that's a unit vector. And if that's a unit vector, it has to sit somewhere on my unit circle. It's not one of my special angles. It's not one of the angles from my special right triangles, but that doesn't mean that it's not on the unit circle. It's just not at 30 degrees or 45 degrees or 60 degrees. But it still is a vector that has a length of 1, and so it would be a point sitting on a circle of radius 1. And so that's how you find unit vectors in the direction of a vector, and these come in very useful in some later applications that we'll go over next week.